Welcome to another edition of Sudoku and Variance, where I teach you how to solve Sudoku and Variance the easy way. Today we're solving an easy 8 by 8 Sudoku. The rules state that we must put the numbers 1 through 8 in every 2 by 4 grid, and in every row, and in every column, without repeating any numbers. When solving a puzzle like this one, it is useful to know that the numbers in the upper left of a 2 by 4 grid will be the same numbers used in the bottom right grid. Notice that in column 7 we have a 7 and 3. In the bottom right column, in the bottom right of column 8, we have a 7 and a 3. Let's look at column 1. Now I see a 5, 2, 4, and then in the bottom right I see 5, 8, 4. I can put the 8 on top and the 2 on the bottom. But why? Well, we can't put another 8 in the same column as an 8. This is why we can't put we can't put an 8 below the 6. I put the 8 in the only empty square on the top left, and put the 2 in the bottom right square. Looking at the top grid, we are only missing one number. I simply count until I can't find a number. That's 1, 2, 3, 4, 5, 6, 7 is missing, and that is the number I fill in. Notice in the bottom left of column 1, there is a 7. If I would have looked down there, I would have also known that I needed a 7 in the upper right area. Now that column 2 upper right has a 3 and a 6. I know I need to put those numbers in the bottom left of column 1. I will look at row 7 and see if I see a 3 or a 6. 1, 2, 3, 4, 5, 6, 7. I do see a 3, which means I cannot put a 3 in this row. I put the 6 in this row instead, and the 3 in the bottom row. Moving on over to column 3. We have a 4, 1, 7, but in the bottom right, we only have a 1. I will instead try and put in the 4 and 7 in the bottom right. I look at rows 5 and 6 and see 4s. This leaves me only one spot to put a 4. I then look for a 1. I already have the 1, so let's look for a 7 instead. I see a 7 in row 6, so I put the 7 in row 5. Now I only have one number left, but don't know what number that is. I can look at the upper right and put those numbers in the bottom, which should give me one number left to place. Or I can make it more complicated and simply count in numerical order the numbers. This is because I know that the 6 and 2 is the only numbers that can fit in the bottom left. So I simply count 1, 2, 3, 4, 5 is missing, 6, 7, 8. I put in the 5 in the bottom, and on the in the bottom right, and on the top left. Notice also that the top row 1 only had one missing number. Thus, 5 being missing was obvious. Okay, I look at row 6 for a 2 and I see it. Thus, I put the 6 here instead. And then put the 2 in the last spot. Moving to column 4, I need to place the 8 and the 3. I do not see an 8, but I do see a 3. This means the 8 must go in row 2 and the 3 in row 3. Column 5. Column 5 has an 8 on the bottom, and column 6 on top is only missing the 8. So I put that in. Now I see the bottom of column 6 has a 4 and a 5, but does not have a 6. And column 5 has a 4 and a 6, but does not have a 5. I will look at the top for a 5. And see it in row 2. Thus, I know the 5 must go in row 4. I look at row 5 for a 6 and see one. This means that 6 must go in row 8. I put in the last missing number, the 2, and then move on to column 5 to see what else I can do. Have 1, 7, 8, 3 in column 6 that must go at the bottom of column 5. Okay, row 5 only needs one number. I see that the 3 is missing, so put that in. Row 6 is missing only the 1. This leaves me with only the 7. Moving on over to column 7 bottom and row 8, I only need to put in the 5. That is the only number missing. So looking at column 5 again, I am only missing one number, and because the bottom left has a 2, 4, 5, 6, and the top right has a 4, 5, 6, but no 2. I know that I can put the 2 in that empty spot. Now row 2 is only missing a 1. Row 3 is missing a 4 and a 5. Looking at the bottom, we see a 5 on the left and a 4 on the right. This means that the 4 must go on the left on top, and the 5 goes in the right on top. Lastly, we have I have column 7, missing an 8. And column 8 is missing the 6. Now, notice the pattern that the numbers make. We have 7, 3, 4, 8, which equals 3, 4, 7, 8. And in the bottom right, we also have 3, 4, 7, 8. And the upper right has 1, 2, 5, 6, and so does the bottom left. And there we have it. We solved our first 8 by 8 easy Sudoku. I am Keith, and I thank you for solving this one with me. Please like, subscribe, and share. I hugely appreciate. Thanks again, and have a wonderful day.